So today I'm going to talk about a small pet project that I've been working on together with my colleague Orkan Telhan from UPenn on and off for the past 10 years. I'm heading at Northeastern Information Design and Visualization program, and of course it's always fun to play with large data sets and explore what they contain. But I found myself more and more drawn to questions of the material and social conditions under which data sets emerge. And I'm going to talk today about visualization principles for material information. So talk is divided into 4 parts. First, I'm going to talk a little bit about data visualization and its limits. I'm going to talk about what we mean by autographic visualization. And I'm going to go more into design principles and rhetoric techniques of autographic visualizations before I conclude with some of the limitations. So let's start with the things that visualization cannot directly show, and I want to explain this through an example. So last year, state of Florida passed this legislation that allows parents to object content of textbooks used in science classes in schools, and the conservative Heartland Institute from Illinois sent out this publication to every public science teacher in Florida. And no spoiler, it's of course a climate change skeptic publication. It looks like a legitimate academic publication with lots of charts and references. And I want to talk briefly about this chart that warns us that we are headed towards a new ice age. So it's based on data derived from ice core samples in Greenland using the isotope ratios as a proxy for temperature. The data is based on a legitimate source, data set by a professor from Penn State University, Richard Alley. And everything is correctly labeled and annotated. There's just one small detail. If we look at this very, very last data point, I don't know how to, maybe I can, is there a pointer? Oh yeah, this very last data point here, this actually represents the year 1855. And that's not, that of course takes out some of this drama makes the evidence a little bit less compelling, and that's related to some of the conventions in paleoclimatology. And the author David Lapie actually painted it red as an obvious reference that this kind of minuscule amount of warming to contrast it with the famous hockey stick chart. But of course, I don't need to preach to the choir. I'm interested in something else. One of the less controversial principles of data visualization is to focus on the data. So according to Ed Tufte, everything else is suspect of being chart chunk. And at best, this chart chunk is a distraction, and at worst, it's a lie. So considering this principle, the previous chart did not commit any major crimes. So of course, it's not the most pretty chart, but it shows the data, it provides sources and context, and yet it's really misleading because we miss the relevant context. The problem is, if you go to the FTP site to download the original data set, it doesn't give us a lot of context either. So we just get these 2 columns of time and temperature. So the chart shows us a very convincing, appealing pattern. But of course, the data set doesn't really tell us the whole story without the whole context of paleoclimatology. So as we see, this principle is, above all else, show the data is a little bit more complicated because we have to know actually, where in the chart is the relevant information, what is data. To Tufte's credit, of course, he always emphasized the importance of context and understanding how data are generated. But I think this example is somewhat symptomatic of a particular issue in climate change discourse, that what we know basically from abstract models, but these models are somewhat disconnected from the world of sensory phenomena, the world of sensory perception. This is, of course, the way how science today works, but there are situations where we want to reconcile data with our sensory perceptions. Now, I would argue that the methods of data visualization, as they are currently set up, increases this decontextualization of data by focusing only on its internal structure rather than the external context. So this is a little bit how it works. We start with a data set. We can't do anything before we have a data set. Then we explore the data set, look for patterns in order to understand a phenomenon. But there's a gap between data and the phenomenon. We are basically locked into the symbolic space that is defined by the data set. So now let's move to autographic visualization. This is a picture of the data source of the previous data set. This is a picture of a Greenland ice core. It shows the annual layer structure, so it's actually a visualization itself. It is a proxy data source. Paleoclimatologists have quite a lot of those, the tree ring networks that span global scope. We have bioindicators. It's all an active area of research. So this ice core image is a visualization in itself. Of course, not all relevant qualities and very few of the relevant qualities to produce the temperature predictions are visual, but many of the qualities are made visual through the material treatment of the sample, of the object. That starts with the way how scientists figured out in the 50s how to produce these ice cores in the first place without destroying everything. And this is an image of the archive where ice cores are stored. This is the NSF facility in Denver, Colorado. So there are, of course, material implications. Last year, university in Edmonton, Canada, has lost a third of their ice cores during a power failure. But what I'm getting at is that data is a more universal concept. The data visualization universe is mostly limited to symbolic data. By symbolic, I mean encoded observations. This is, of course, a very narrow concept. Archaeologists, for example, describe those pieces that they pull out from the ground as data. And philosopher of information, Luciano Floridi, describes or defines a datum in the broadest sense as a lack of uniformity. Or with Gregory Bateson, from anthropologist from the 70s, who famously said, a bit of information is the difference that makes a difference. So we are used to deal with symbolic data. All our world, our mediated world surrounds us with symbolic data. And we treat them as abstract and transformable. But of course, the underlying concepts and the units still have, still often have a sensory grounding. This is a nice example if you think of the concept of color temperature, which very literally translates a visual phenomenon into a physical unit. So, to sum up, autographic visualization is a set of techniques for revealing material phenomena and guiding the interpretation. Autographic means in this case that the phenomenon reveals itself, it presents itself, and it inscribes itself. But this doesn't happen by itself. So we need a set of design operations for revealing material information. Interesting example like the windsock, for example, where I didn't know originally that the number of rings that you see actually translates to the wind speed in knots. So it's quite sophisticated, although very simple. So if we make the same simple diagram for autographic visualization, it would look something like that. We start with a phenomenon and look at the material conditions of data collection. Notice we are not going back to the 18th century of natural philosophy where everything is based in the senses. We use data, but we want to understand how data are generated in order to understand the analysis. Of course, there's another gap here because we can do a lot of things with data that we cannot really do with material information. So autographic visualization exists in a very rich cultural space. And over the years, we collected a lot of examples of such practices. There's a Pinterest board where you can browse some of these examples. So I'm talking about phenomena such as traces, symptoms, specimen, and so on, which are produced or analyzed or transformed in the sciences, let's say forensic sciences, archaeology, and so on, but also in ancient cultural techniques such as hunting or agriculture, wayfinding, and these things. So traces as these kind of autographic visualizations are a very interesting topic because they're in between a lot of things. They resist being pinned down with a very clear definition. So there are a couple of questions that come to mind. So one question is, how exactly is reading a trace different from reading a visualization or reading a visual sign? What makes a trace meaningful? Is the meaning something that is located in the object, in the material world, or is it in the interpretation? And most importantly for this discussion, are traces something that are discovered, or is it something that is constructed in the act of reading? Even if we take something simple such as tree rings, we still have to cut down a tree in order to see them. So there are always cultural techniques and specific ways of looking connected to those. So they're not purely discovered, but they're also not purely constructed. Those questions are actually from a book that unfortunately is not available in English by Sibylle Krämer and colleagues from Humboldt University. And in German philosophy and media theory, there's a lot of work that deals with traces and their kind of epistemological implications. Unfortunately, none of that is translated to English as of now. Until recently, Orkan and myself, we talked about these phenomena in the context of indexical visualization. Indexicality is a term that comes from classic semiology of Charles Sanders Peirce. And this is how it works. So we have three types of signs. We have symbols, we have icons, and we have indices. So the line in the middle is a symbolic sign that is defined by a convention, cultural convention. The iconic sign works with similarity, and the indexical sign works through an existential connection between what we see and between what has happened. So there's a kind of causality implied. And we chose this framework mostly to make a point that data visualization and information design has a lot to do with symbolic representations and with iconic representations, but the indexical sign is completely absent. So what would a visualization language that focuses entirely on the indexical signs look like? Over time, however, we found this semiotic framework both a little bit too limiting and both a little bit too broad. For many reasons, we think that the autographic quality of traces is a little bit more accurate as a description. So now I want to briefly compare those two paradigms, data visualization and autographic visualization. In data visualization, we start with the data set. In autographic visualization, we look at the process of data generation and end with the data set. So this means that data visualization looks inwards at the internal structures of a data set, whereas autographic visualization looks outwards at the context, at the implications, and at the origins of a data set. Data visualization is representational, so you have a visual language that represents something else that is absent, whereas in autographic visualization, the trace presents itself, so it's non-representational. We don't have something absent that it represents. And in terms of the design process, in data visualization, we encode data into visual variables, whereas in autographic visualization, we isolate qualities of a phenomenon. So I want to talk a little bit about related concepts in HCI. One of the most important one is hugely popular field of data physicalization, which I think is very important. And also, a lot of my students and a lot of people produce amazing work in this space. And also psychologists are starting to explore what is the difference between interacting with an object representation of a data set versus a visual representation. However, the big difference here is that data physicalization also starts with a data set. So Yvonne Janssen et al. Describe it as physical visualizations map data to physical form. So we start with the data set. Another recent approach was termed qualitative displays by Dan Lockton and other colleagues from Carnegie Mellon. I see qualitative displays, this conceptualization, very closely related to ambient displays and tangible media, where one of the main ideas is not to kind of explicitly encode something into a number, but rather show a kind of ambiguous image that represents certain qualities and provides a certain richness. So it connects a little bit to that. Indexical visualization, a number of people have worked on that, including myself. And I think the one that is most closely associated with what we do is the notion of self-illustrating phenomena. Pat Hanrahan described it in a Viz talk in 2004, but there was never something published about it, except the book on the history of scientific image making. And he described self-illustrating phenomena as an image that is generated automatically as a result of an experiment that exposes the phenomenon behind the observation. It represents an answer to a question. So I think there's a very direct connection here. In this case, however, self-illustrating phenomena were mostly limited to scientific image making, and there's a lot of theory in media theory and history of science that deals with image making practices in the sciences. But many, and there are many more, most of them agree that visualizations, data visualizations, and physical phenomenon have a certain kinship. So we read certain physical phenomena similar to how we would read a data visualization. So now we could talk a lot about what exactly constitutes this relationship. Is it about metaphors, or is it more about organizational principles that are so universal that even animals can find them? But I think there's a lot of interesting space here to explore. But importantly, also historically, those two things were really treated in the same way. And I want to go back to Etienne Jules Marais in his groundbreaking book first published in 1878, on the graphical method. I'm really surprised that this book doesn't exist in an English translation. And Marais, in his book, he describes the graphical method, and he spends a lot of time talking about statistical graphics and its design principles. He has, of course, the famous train schedule chart, which was later reworked by Ed Tufte. But he quickly proceeds to other things, things that followed him through the rest of his life, where he described strange mechanisms for recording traces, such as recording the pulse of a person. This was related to his own dissertation in the 1850s. Or this is also a very interesting contraption where he tried to encode the movement of a bird as it flies by connecting the bird with wires to this machine. Of course, he quickly moved to a little bit less cumbersome technique, and he is mostly famous for his chronophotography, high-speed photography with multiple exposures that he developed. And he was so happy with this image of the flying gull that he also had it rebuilt as a wax model. Interestingly, not as small multiples, so to say, but as a single object of a bird that is compressed together. So he also included data physicalization in his work. And importantly, he also created an early prototype of the wind tunnel. And I think the wind tunnel is the most beautiful and most iconic example of an autographic display, which we call the smoke machine, where you would be able to look at turbulence through smoke traces. And just to give you an idea how the object looked like, the smoke machine, so this is pure steampunk with this chamber. And in the spirit of Marais, we also have a lot of cases where visualizations and traces are one and the same thing. If we think of the seismometer or the seismograph that produces a line chart, which is at the same time a physical trace. So this now brings us into some kind of conceptual dilemma, because if this line chart is at the same time a physical trace, what exactly is the difference to, let's say, a satellite image or a sensor that is connected to a computer that automatically records something on a hard disk or prints it on a screen? So those are, of course, also physical traces. So data visualizations are often literally physical traces, but that is a little bit absurd because it would kind of make it very confusing to talk about these things. And I can illustrate it with an example. If we take GPS data, like here in a famous public data set of New York taxi cabs, we just have two numbers, latitude and longitude. And if we print them all in a two-dimensional space, unsurprisingly, we have a map of the city. But what is interesting, if we look at this kind of blurry area, can anyone guess where this blur comes from, what that might be? And what makes it blurry? Yeah. So exactly. So of course we have tall buildings, and the tall buildings disrupt the GPS reception. So in other words, we have information about the third dimension of the city just based on this artifact of the GPS data collection. So I would argue that even data sets, we can read a data set in two different ways. We can treat it purely symbolic and look at only patterns that are internal to the data set, or as in this case, we can look at the external context of the material data collection. So we don't know that this is actually because of tall buildings if we only look at the data set. We have to understand how GPS works, all these kind of material processes that happen. And if we take this material reading of a symbolic data set, we can get additional information, such as the building height, versus in a classic data analysis paradigm, I would probably delete all the points that are in the ocean and delete all the points that are within the building just to kind of remove the obvious mistakes rather than using those artifacts as a source of information. Now, we'll talk about that later a little bit more because there's many cases where digital information plays a role in these kind of forensic techniques. So let's briefly talk about autographic design operations. I will limit this only to the manipulation of indicators. You have a phenomenon and you have an indicator that illustrates this phenomenon, and you can manipulate this indicator to make the phenomenon visible. Two of the most basic design principles of autographic visualization are framing and encoding. So if you consider this, it's called a cyanometer. It's this 18th century device for measuring the blueness of the sky, for example, as a proxy for humidity. So this device makes a lot of sense in this conceptualization of the climate from the 18th and early 19th century, where climate was understood as a physical, as a sensory phenomenon rather than a statistical phenomenon. And what framing does is that framing transforms the way how we see something. So if we look at the sky through this cyanometer, we see the phenomenon differently. And if we encode it into this kind of quantitative scale of blueness, we again see it differently. And this can easily be illustrated. You can try this out if you go to New York in James Turrell's installation meeting. And I was surprised myself, and I noticed other people there as well, who just didn't recognize that this blue square at the ceiling is actually the sky. It's just a hole and you see the sky, but it looks in a way so artificial and so decontextualized. And this is, of course, exactly what James Turrell wanted to do. He wanted to mess with our color perception. But this also shows us that framing really changes a phenomenon. And in art history and photography, there's a lot of theory around that, how that works. A second design principle is the one of constraining. So if we think about the mercury in the mercury thermometer, mercury has a lot of properties, but we are only interested in the thermal expansion. So we have to constrain everything else and have only the thermal expansion as the only visible variation. And then again, we have here the principle of encoding with the scale. It's fascinating to read the letters that Daniel Fahrenheit wrote when he constructed his thermometer to realize how difficult and how complicated such a banal object is if you design it from scratch. So we tend to kind of forget this and take all of these things for granted once it works. Constraining can also be very literal, like in the case of the poor canary in the coal mine, who would entertain the coal miner, but also warn him of imminent danger by its own death. But Sentinel species play a big role in the environmental sciences, such as mussels are a good proxy for data quality, for water quality. And Sentinel species are often used because they are both faster they can be cheaper and more accurate than actual digital sensors. So there are a lot of practical reasons to use them, not just for school science class demonstrations. The next technique is aggregating and separating. So very often we deal with material phenomena, but we have to aggregate them to see them, such as the dust mask, where we suddenly see the air pollution that is otherwise invisible, or separating in the case of the ink paper chromatography that many played with in elementary school, where the ink is separated in its components. But that also is pretty much the same principle as in DNA electrophoresis at work. One point about is that there are many different ways how material is aggregated or separated, but this also raises another interesting point, which is the role of time. So all autographic phenomena are about temporal phenomena. It's always about some kind of process of inscription that takes place over a longer or shorter period of time. If we have a phenomenon that is invisible, but we want to make it visible, we can also couple it with a tracer substance. Here the example with Chladni's figures, where he would visualize sound waves by adding sand on the vibrating object. And there are many, many different ways how tracer substances visualize things by letting a phenomenon interact with something else. So now those were a couple of basic design principles. Now I want to look at how those things play together. In, for example, autographic environments, again, the wind tunnel, a great example, where we have tracer substances, we have a constrained environment, so we have framing, we have all of these things. This is a project by an artist, Florian Dombois, who builds wind tunnels. And Clemens Winkler, another artist who builds cloud chambers, and his ultimate goal is to create a rectangular cloud. I don't know how far he's along that route, but it's again, you're building experimental apparatuses that also in the history of science played a very big role. So I want to talk also about digital physical systems. Here I have to give credit to my old students in Austria who built this installation for Ars Electronica 2007 called Garden of Eden, where they visualized air quality in different cities of the world by polluting salad plants driven by data. And interestingly, I'm coming back to this project now because I've become interested in practices of planting ozone gardens, which is another thing that takes place in the US also, where certain plants are very sensitive to ozone, and you can really observe them and register ozone episodes. And last, of course, also work with living materials or bacteria or smart materials, where the idea is to design materials that have autographic qualities. There are also a lot of examples here. So ideally, we have a way where data visualization and autographic design can work together. And in my next part, I'm going to talk about some of these practices that already do that in citizen science and other areas, where both symbolic data and autographic design plays together. And of course, this is very often done for rhetorical reasons to make a point. One of the first goals, most prominent goals, is to make it possible to experience causality, because traces are always very connected to causality, or to use traces as signals of authenticity. So I'm going to start with an example from citizen science, public lab here in Cambridge, very well known. Also one of the co-directors, Sarah Wiley, one of my colleagues at Northeastern. She works on this project, Materializing Exposure, where they use photo paper to measure the impact of fracking. The hydrogen sulfide that emanates from the ground taints the photo paper dark, so you can use it as a sensor. And they developed this into a citizen science technique. And when they do this, interestingly, they create these maps that are at the same time symbolic representations, maps, but also contain these physical traces. So this is not how you would do it in, let's say, paradigm of cartographic communication theory. But I think it's no coincidence that those kind of practices especially emerge in citizen science, because citizen scientists are often outside the institutional space. So what the data sets that they produce are often subject to extra scrutiny, because anyone can make up numbers. And by showing the original trace, this is of course a rhetorical tactic of demonstrating or underlining causality. A second reason why we see this very often in citizen science is that those groups work with communities on data collection. And to have this very visceral and tangible way of collecting data, this also is a tool for engagement. So it's more fun, and it's maybe more convincing to see what is actually what actually happens if you see how the photo paper darkens. So those are two ways. So how exactly does this work? You could describe it as annotated walkthroughs to guide the observer or the participant through the process of interpretation. So this is another example from a paper that I recently published on amateur forensics in the Syrian war, where it was the first war where where social media played a very central role for information warfare, also for reporting back to financial funders of different armed groups as a tool of communication. And then you had these online communities of conflict mappers who would scrutinize those horrible videos on YouTube and in different social media channels, and try to figure out what is really happening. And one example here is where one group would basically claim to have captured a city, and they would post a video as a proof. But then those crisis mappers would come and look at the position of buildings and triangulate it with Google Earth or other tools, and then find out that actually this particular location is at the outskirts of the city, not in the center. So it's refuting the claim that the city has been captured. Now, of course, they could just say that, but they are posting the original raw footage from the web as a form of tableau to make this point. So in order to, and they use this very simple annotation in a quite clever way to show what are the same elements in those videos. So in other words, this is they are walking the viewer through to make the work of the cartographer themselves. So this has been sometimes described as non-representational cartography, because it's not a simple act of representation where you just present someone with the result, but you basically make them work and make them connect the dots in order to figure out the conclusion. last point, where I want to connect back to data collection methods that I call sensory accountability as a form of accountability of data collection methods and metrics and thresholds. And this is from a recent art project I did in Germany earlier this year in Stuttgart. And Stuttgart is a city that has a notorious relationship with air pollution. It's a kind of very polluted city, although pollution is always a relative term in the global scale. But well, it's a big political issue nevertheless. And you have citizen scientists who built an impressive network of dust sensors, and you have the city who disputes the claim. And very often those political controversies revolve around what is an appropriate threshold of exposure, how should we think about that? And all of those metrics are actually not ideal. The particulate matter, the gravimetric unit that is used doesn't really capture all those dimensions of air pollution. So my approach was to make the actual material of air pollution visible. So this is, for example, a test strip from a gravimetric analysis where you have this filter in a sensor. Usual digital sensors work with a light barrier where they just register if a particle obstructs the view and basically use that as a proxy. But the accurate lab method is to collect the actual matter and weight it. So this is how it looks like. And I thought that, okay, so this matter not only accumulates on these test strips, but basically everywhere in the city, on every facade, on every surface. So basically the whole city is a visualization of air pollution. We just cannot see it, but we lack the framing, we lack the tool to make a visual comparison. And so I used this technique called reverse graffiti, which works like this. So you basically just use a stencil and a pressure washer to clean surfaces and create patterns. This is very often used by activists because legally it's not graffiti, so they are not adding any paint, and so they are not destroying anything. They're just cleaning something. And of course, cities don't really accept this claim very easily. And so we had to go through a very rigorous process of getting the permissions to do that, even though nothing much really happened. But so we created all over the city these reverse graffitis. And the way how this is designed, of course, this is a visual reference to these gravimetric strips. But you also see this half-toning pattern, and they will disappear over time. So after 6 months, they're mostly gone. And first one is probably this very subtle one that will disappear first. And so you get a sense of how these things will slowly disappear in order to observe the process of air pollution. Of course, this is not just particulate matter, what is on these surfaces. So that's an obvious problem for a scientific way of measurement. But of course, the official ways of measuring air pollution are also not perfect. So it's a little bit about these mutual imperfect methods of capturing a phenomenon that is now often described as the exposome, that is a qualitative, very complex phenomenon. And I also wanted to connect it back to the digital data. We used a sensor and put in the microgram average exposure over the past month, and built a website where you can watch the real-time result of the sensor network and look at the photos of these different dust marks in the city. So I'm interested in juxtaposing the material phenomenon with the digital data, and in order to basically ground this discussion more in the material dimension. So to finish up, of course, we have to be careful when we deal with physical traces. And we shouldn't really take physical traces, equate them with evidence. And there are good reasons. There are a lot of examples of evidence that are not really convincing and not really, they might be convincing, but they don't represent causality. And we have a lot of material evidence of UFO sightings or other things, of footprints of humans next to footprints of dinosaurs and things like that. So if we go back into this mode of fetishizing material evidence and traces, this would be a kind of a shortcut of looking at the naive empiricist position. So ultimately, when we experience causality, we are actually speculating. It's a mode of speculation. And historically, traces, even if there is a clear causal connection, have often been overinterpreted and added with ideological beliefs and positions. And the history of the fingerprints and forensic identification is a good example of that. Francis Galton, originally he was really interested in fingerprints. I mean, it was for a long time, it was clear that fingerprints somehow identify a human and that they are somehow unique. This was not exactly a new idea, but Francis Galton, as a eugenicist, he was interested in learning about behavioral qualities from analyzing fingerprints, whether someone will become a criminal or not, or also tried at least to distinguish or to derive the race from a fingerprint. But of course, the trace presents itself. It doesn't really tell a story, so we can project a lot of things into traces, and fingerprints have resisted being correlated with race or anything else. And of course, all other forensic modes of identification, which at some point were considered legitimate science, not junk science or fringe science, such as Bigfoot or UFOs, fall into this trap. So this is not the point I want to make. I'm really, on the one hand, more interested in this process of data generation and making it more accountable. But on the other hand, I think there's an important point that we often overlook in data visualization, where we basically treat the visualization as a stable artifact. And whether you understand it or not is just a question of visual literacy. And if you don't understand it, there's a way to learn it. In autographic visualization, it doesn't really work like that. So everyone sees traces slightly differently. A musician hears auditory phenomena different from an untrained person. Architect sees buildings differently. And I'm arguing this is not just a difference in interpretation, but the actual perception, the phenomenon presents itself differently. And if we use this, if we take this seriously in a mode of autographic visualization, we have to put the observer, which now becomes a participant, into the center. So we cannot basically remove the participant from the process of visualization. And the participant cannot just learn how to read it, they have to tune into this phenomenon to really become sensitive. And there are fascinating ethnographies of hunter-gatherers that, of course, they have amazing skills at really reading the tiniest things into a spoor, into an animal footprint. But then often they also make mistakes, so they kind of go back and figure out certain things. And so it is an epistemic process of knowledge generation. And what I like about it is that it turns the process of visualizing something into kind of an experiment where the outcome is not always completely clear. And yeah, this is basically where I want to leave it today and open up for questions. I have a couple of references, if you're interested in reading the papers or looking at stuff here. We also did data stories on the subject, which was a lot of fun. And yeah, thank you again.
All right, so we've got some time for questions. We have microphones, so raise your hand, and we'll bring you a mic.
Thank you. It was a great talk. Thank you so much. You talked about autographic visualizations not being, like the result of it not being apparent when you start. How do you prototype or test before you actually go full scale?
Well, with the with the reverse graffiti, I was very nervous because I really didn't know whether it will work or not, and so it was actually an experiment for me, and I learned a lot in the process that it doesn't really work on certain surfaces. Untreated concrete surfaces are the best. They create an amazing contrast. So, those are not kind of scientific questions, but it's a practice. It's a way of figuring out how to do certain things that always have to be part of it. Well, how to prototype it? Yeah, that's of course a little bit harder than in data visualization, where the mode of evaluation is maybe a little bit more streamlinable. So yeah.
We have another question back here.
Hello. My question is that if we ought to start from the phenomena and then go to the data, but if we are like trying to figure out the phenomena by going into the data first, right? So like how to do the iterations, because mostly what I do is like I try to figure out the phenomena by going into the data. So how to start with one?
No, I mean it's definitely true that basically just going into patterns, looking for patterns which then make you curious about exactly what's going on here. You find a pattern, you take it as a signal for something that you don't understand yet, and so this is this kind of back and forth, which is also the same as this process of tuning that I'm talking about. So I don't really see it as as something that is completely different, but I think just if someone gives you a data set, you are pretty much limited by how far you can get with this approach if you don't have a lot of context. And in the public discourse, those things matter. I mean, people can find all kinds of patterns in all kinds of data sets and present them as evidence, and then it becomes really hard to basically go back and forth and to basically ground this again in the material reality. I mean, this is what I think would make sense if you ground it also in your physical environment.
Wondering, in terms of making data more perceptible, how is there a way you would approach the data that's generated from online websites and clickstream data and just the massive amounts of data we have on the web? Because it's a result of real phenomenon, but how do you make that perceptible? It's not like an environmental, physical phenomenon.
Yeah, that's a good point. It's a social phenomenon that, of course, is also material in a certain sense. But of course, I mean, we are surrounded by symbolic data, and it's part of our world. It's an increasingly significant part of our world. And yeah, I mean, for these kind of things, I had a couple of examples where indexical principles could be translated to data that come from a purely digital source. So there's one example by, I forgot, a British information designer who visualized the casualties of the Iraq War as a data visualization. And what he did is he picked exactly 1 pixel for every person who died. And that, of course, creates, again, a kind of an indexical relationship. Because now you're no longer variable in scale. You cannot scale it up because 1 pixel really has a specific meaning. And that would be a translation to kind of, bring back this kind of existential relationship between the data set and its representation into a digital space.
So what would you do with the climate change data?
So good that you ask. We have an exhibition coming up with our friend Ben, and maybe too early to talk about it. But there are, I think, many related phenomena. It's not just the average global temperature is not the only way to think about climate change. If you foreground all the different proxy data sources, if you look at bioindicators, behavior of insects, and all those things are also following a very pragmatic way. If you look at them as data sources, for example, looking at certain insects that inhabit tree barks. Those insects are not necessarily selected because they are very best indicators, but because the forestry industry collects a lot of data about these insects. So there are a lot of proxy data sources are always also an opportunistic data source, but they also highlight a lot of implications. So the fact that those data sources are collected already tells us something about their implication on the real world. And I think things with even ozone impact is related to climate change because it originates from the same source, and the increasing temperatures also make ozone more likely to be generated. So the set of relationships is very dense, and there are a lot of things that you can start from.
So I guess kind of follow up to that. How do you control for biases in proxy data sources without going crazy?
Yeah, I mean, I think the example that I showed in the beginning is one of these indicates that, because the falling temperatures are actually patterns in the data, but it's just local. It's just a local effect in Greenland. And I think the autographic visualization can never do those things that data analysis excels at. From this kind of statistical big data approach, we can control for biases. We cannot really do that very well in a kind of physical experimental setup. What we can do is show or kind of understand the process. It's more about understanding the process itself. But I think it's not an alternative for working with data.
What do you think of data science as a profession?
How do you mean this question?
I mean it in the sense of and the continuum between somebody who's simply coding in the sense of programming and somebody who's practicing in the sense of the architect or the doctor. In between those, we now have this very large growing cadre of data scientists.
Yeah, no, I mean, I think when I, during my PhD, I learn statistics in a very traditional way, how you have a controlled experiment and then you analyze the example and build models from it. And of course, how data sets, the availability of data sets have of course changed all of that, because those data sets, okay, we have much more data, but those data sets are also opportunistic data sets. They contain all kinds of biases. So the focus of the profession has shifted. I mean, this is of course obvious stuff, but I would say that good data science also requires the acknowledgement of these material processes, as in the example of the GPS data, where you have to understand the physical processes that generated the data set, or the social process that generated the data set, knowing that this is also speculation to some extent. But yeah, I think there are a lot of interesting points of connection that traditional statistics did not really acknowledge.
Listening to what you're saying, it's interesting to realize that thanks to technology, we're basically blurring the divide between culture and nature, for the lack of a better word. And I think that when we're doing this in terms of the indexical aspects, or the way natural phenomena display themselves, or we let them display themselves, isn't there also an interesting direction towards culture, where a lot of recording and representation of phenomena has been done since the cave paintings, and exploring that landscape the same way we're interested into the so-called unknown is quite interesting, because I believe there is language that has been used that might be interesting in terms of describing, or things that have been described in a certain way that we forgot, or they are no longer part of our cultural discourse, current cultural discourse.
I absolutely agree, and I think like a lot of cultural practices deal with producing traces and analyzing them, but it's often kind of disconnected. It is not seen through a common lens, and very often it's not even seen as a visual practice. When you read a paper or when you look at appendix of a book about the methods of data collection, it's a very bureaucratic representation usually, where we did these kind of things. But if you actually looking at the processes, they're actually visual processes very often, or sensory processes. And I think what I'm interested in is, by connecting a lot of these ancient and modern practices, by looking at them as visual practices that share many similarities in all of these areas. So,
yeah. I was struck, Dietmar, by the way you framed it right at the beginning, this relationship between the data and the phenomenon and analysis. And what I've found in many of the examples from like late 18th or early 19th century visualizations, and the trace example that comes to mind was, there was a machine that was built in the late 1700s or even before that, for recording wind speed, that actually it drove a pencil that that would draw something on a drum that was rotating, right? And they recognized this as an interesting phenomenon, but it was useless if it wasn't turned into numbers. That initially people didn't recognize the value of the visual trace unless they could turn it into numbers, in the same way that many of Playfair's early work wasn't trusted, because people just wanted to see the numbers. The pictures were nice, but if it was valuable information, it had to be quantified. So this ability to read the landscape, or to read the phenomenon that you're describing, is as we've all said, has a long history. It's interesting to bring it back.
Marais also talks about that in his book as of, yeah, statistics, okay, this is kind of the simple stuff, but science, that's the more important thing. Historians of science and philosophers often talk about this shift from a sensory-rooted concept of science to a number, computation-centric one, and somehow locating this somewhere between mid-18th century and mid-19th century. It's a shift from experimentalism to more theoretical-driven approaches, and of course, there were good reasons for that, but I think there are also reasons now. Now we take the computational, grounded paradigm totally for granted. This is just a natural way how we engage with our environment. So I think it's a good idea to also look at the kind of physical implications of these things. And so in a way, I don't really want to go back, but I think it's an interesting way to. And I see a lot of people now. Since we started working on that like about 10 years ago, and it was considered so esoteric that nobody would be interested in it. But now I see a lot of people are interested in kind of material phenomena as information, as data. And of course, in the current theoretical discourse, it's all about materiality, or almost too much at this point. But it is definitely, there's a certain perception that this is something that's becoming more important again, I think.
All right. Any last questions? All right. Well, I'd like to thank Dietmar for the wonderfully engaging talk. Thank you very much.